Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in computer organization and architecture. We're going to start unit 4, basic processing unit. And in this video we're going to see very important concept about the processor. We're going to see single bus organization of data path inside processor. We're going to see how the processor performs various operations. And we're going to start with fundamental concepts, and then we will see about the basic organization of the processor. Right. So before starting with the single bus organization, first we all know that what is the importance of processor in computer, right? So this processor can be called as just a processor or can be called as instruction set processor, right? Because we have already seen in unit 2, right, that is in order to execute any particular instruction, right, all the instructions will be executed by the processor, right? That is, for example, if you have any instructions like add R1, R2 or move R1, R2, something like that, right? Any instruction, right? Any instruction or any program, right? A program is nothing but a list of instructions, right? So all these instructions will be executed by the processor in a sequential order, right? One by one, it will fetch the instruction from the memory and then it will execute it, right? So this particular processor can also be called as instruction set processor, right? And it is very commonly called a central processing unit, CPU of the computer, right? But right now in modern computers, right, the processor may not be called as central processing unit. That's because in modern computers we have more than one or two processors of that, right? That is, in order to like super fast computers, in order to improve the performance of the computer, right now in modern computers we have more than one processors, right? So right now it cannot be called a central processing unit because it is not anymore only one processor in the computer. We have more than one processor right now, right? And the very important working of the processor is it performs all the operations, right? So whatever operations or whatever instructions which is given to the computer, it will be executed by the processor, right? Of course, the processor will get the help of ALU, all the registers, everything, right? But the complete operation is organized by the processor. And today we are going to see about how these instructions are getting executed, okay? And before seeing the instructions getting executed, how it is organized, right? We have already seen something called operational concepts in unit 2, right? So this is the basic operational concept, that is how the processor execute the instruction, right? That is what we have seen. You have already seen this diagram, right? We have explained in detail about this basic operational concept already. So if you want to know very detailed explanation about this, just go and watch that particular video, right? So I'll just give you an overview of this operational concept, right? We know that memory will have the list of instructions, right? It will have the list of instructions. All the information will be stored in the memory, right? And the processor, what it will do is in order to execute the instruction, it will fetch the instruction from the memory one by one and then it will execute it, right? And in order to do that, we know that there is something called memory address register and memory data register, right? So what is memory address register? You know that memory address register will have the address information, right? And MDR will have the data information, right? And very important registers is program counter and instruction register, right? Program counter is the one which will tell you what is the next instruction that is going to be executed, right? That is, the instruction execution will start at the first step only at the program counter, right? The very first instruction, like whenever there is an instruction in the program counter, that instruction will be executed, right? Right. So whatever information which is executed next, that will be present in program counter. We know that, right? And similarly, you know that instruction register, it will have the information about the current instruction which is executed, right? And you know what is MAR and what is MDR, right? So processor will get the information, right, through MAR from the memory, right? And after that, it will execute that instruction, right, using ALU, and then it will store the result in the memory using MDR, right? That is the basic operational concept, right? So, right, in detailed about, you can, if you want to know detailed operation, just go through the operational concept video, right? I'll give the link in the description, okay? Right. So here, the main thing is, you know that for any instruction that is going to be executed, you have two phases. One is fetch phase, another one is execute phase, correct? One is fetch phase, another one is execute phase. So what is fetch phase, right? Fetch phase is nothing but like whenever the instruction execution, that instruction execution will start at the very first step when it is in the program counter, right? So fetch phase is nothing but from program counter, right? It will reach the processor, right? That is from program counter, it reach the MAR, right? And from MAR, right, it will get the information about that particular instruction, right? And it will be sent to the MDR, right? And MDR, it is sent to the IR, right? And until it reaches this particular IR, the fetch phase will happen, right? The instruction will start from PC, go to the memory, MDR, and then IR, right? Right. So once it reaches the IR, the fetch phase will be completed, and execute phase will start at the IR. Correct? We know all those things, right? So the execution will start at the IR phase. This is where the processor will decode the instruction, right? It will check what is the instruction, whether it is an arithmetic instruction or logical instruction. What is the exact instructions that what is the operation we have to perform, right? If it is arithmetic, what it will do is it will send the information to ALU. Correct? So it will send the data also, which is required for that operation to the ALU, right? And once the ALU performs the operation, it will get the result, and the result will be saved in the MDR, right? And what the processor will do is, if it needs to send it to the IO device, it will send to IO device, or if it wants to store the result in the memory, it will store it, right? This is the basic operational concept. There is no change in this operation, okay? But we have to know how this registers and ALU are organized in the processor, how the exact operation is taking place, right? So that is what we're going to see here, right? So, right. So we will come to this, that is whatever I have said right now, that is instruction register, program counter, how the program is getting executed, how it is fetched, how it has been executed, all those you have to write, right? That is the functional concepts, okay? Right, and as I said, right, that is fetch phase and as well as execution phase, right? So until the instruction starts from the program counter and reaches the IR, it will be the fetch phase, correct? Once it reaches the fetch phase, the execution will start, right? And you got to understand one particular thing. I have said that program counter will have the information of next instruction that is getting executed, right? And once the instruction is moved to the IR from PC, the PC will be incremented by 4, right? If it is byte addressable, it will go to the next instruction, right? You know that program is a list of instruction, correct? Right? All this we have already seen in unit 2, right? So once this instruction is executed, it is completed the fetch phase, the program counter will go to the next instruction, and then it will go to the next instruction, right? And it will be incremented by PC plus 4, right? And once the instruction has reached the IR, the execution phase will start. Okay, this is what we have seen so far, right? And this is the single bus organization of the processor, right? So what is that you have to explain in this processor? You know that the complete operation of the processor right now, but what is that you got to explain in single organization? You got to explain how the processor coordinates all this function, right? We know that instruction is getting from PC and then from MR and then through MDR and then to ALU and then the result is stored. Right, you know all those information, correct? But how it is performed, right? This is single bus organization. You can see here, this is the single bus. It has a single bus, right? This is the internal single bus, okay? And this bus connects all the registers. You can see this register, MAR, MDR, all the registers, and as well as ALU, right? And importantly, it connects the instruction decoder as well, right? Everything is interconnected with this internal bus, okay? But the connection is the connection between the registers and the internal bus is not the same, right? Each and every register have its own connection. Okay, I'll explain that. Okay, and apart from that, there will be an external bus, right? External bus is nothing but address bus and data bus, right? You know that there are three buses: address bus, data bus, and control bus, right? So address lines and data lines will be in external bus. These are the external bus, okay? This external bus can be connected through the memory through MAR and MDR, okay? Right, and control bus, you know that control bus is nothing but it generates the control signal, right? The control signal is connected to the instruction decoder. Okay, so this is what you have to write, right? And then now the very first thing is, you know that program counter is it. You have to write about the program counter. Program counter, you know that it will have information which is going to be executed next, right? So that information will be in the program counter, right? And the program execution will start. The instruction execution will start at the program counter, which means as soon as there is an instruction in the program counter, that particular information will be fetched to the processor, right, through the memory, correct? Right. So that is information about PC, right? And then you know about MAR and MDR. Now listen very carefully. MAR will have only one input and one output, right? That is the it is connected. The input is connected. You can see here the internal bus, right? It is connected to the MAR here, and the output is connected to the external bus. Okay, which means it will get the MAR will get the information from the internal bus and place the data in the external bus. You got it, right? You can see the arrow mark, right? So it has only single input and single output. And if you take MDR, you have two inputs and two outputs, which means it can get the data from internal bus and place the data in the external bus. Similarly, it can get the data from the external bus and place the data in the internal bus. Right. So that is why it has two information. You know that what is MAR, MDR? MAR is nothing but address information. Whenever the processor needs the address information, it will get it from MAR. Right? Right. And similarly, MDR is nothing but it will ask the data. Right? And whenever the processor processes the result, right, it has to send to the IO device or to other register. So it has to be bidirectional. That is why MDR will have two inputs and two outputs, right? And apart from that, you have to know about the general purpose register. This is general purpose register, right? From R0 to Rn-1, general purpose register. You know that processor is having a general purpose register, and the main purpose of general purpose register is for storage purpose, correct? Right? That is temporary storage, right? For example, anytime an instruction is getting executed, it need not go to memory and save that information, right? So because if it go and save the information in the memory, it will take more time, right? So for temporary storage and to increase the speed, right, you need this general purpose register, okay? And then you have to know about this particular registers, right? This Y, Z, and as well as temp. This is another set of registers, right? These registers are very transparent, right? So what is meant by transparent, right? For example, if you take this R0, R1, R2, all this register, right, you would have come across this particular instructions, like any particular instructions like this, move R1, R2, or something like that, right? That is, these registers will be represented in the instructions, right? But these registers, Y, Z, temp, right, it will not be registered, it will not be used for in any instruction. That is, it is very transparent for the programmers, okay? And while executing any instructions for temporary storage, you can use this instructions, right, these registers, correct? So far clear, right? And you have to explain about ALU, right? And you can see ALU, you know that we have already seen the design of ALU, 2-bit ALU, 4-bit ALU, all those things, right? And if you take the ALU, right, you have a control lines like addition, depending upon the operation, you will have add lines, sub lines, XR lines, right? If you need add operation, this line will be executed, right? And similarly, if it is subline, if subline is executed, subline is enabled, then it will perform subtraction, like that, right? And very importantly, you got to understand ALU has only two inputs, one is A and B, correct? Right? And you can see we are using a multiplexer here, right? What is the operation of multiplexer? Multiplexer will select either two of this particular outputs. That is, it will either select constant 4 or it will select the Y, the output of Y, right? That is, you can see here select line, that is the select line will be the multiplexer. It will select either select constant 4 or select Y, right? Select 4 or select Y. right? Because in the multiplexer is the one which gives one particular input to the ALU, right? So it will give either constant 4 or it will give either Y, right? And the other instruction, you can see other information you can get, that is the other input B, it will be directly obtained from internal bus. Got it? Right. And once you get the operation of A and B, it will perform the operation, whether it is add or sub, depending upon these control lines. Okay. And very importantly, after performing the operation, you can see it is stored in this particular temporary register, which is Z. Right. And then that is from Z, it is sent to the internal bus. And from internal bus, if you want to send to any IO device, it will be sent to the input output device. Got it? This is the complete organization, right? And very importantly, you have to know about IR, right? IR is the one, so far what we have seen is, IR is the one which has the information about current instruction that is getting executed, correct? Right. So once the instruction reaches the IR, the processor will decode that particular instruction, right? It will perform all the operation of that particular instruction, right? That is done by using instruction decoder and control logic. This is the one which performs the required operation, right? And there is a control signal which provides control signals to perform all those operations, right? That is, the information in the IR is decoded by this instruction decoder, right? So all this information you have to write in this single bus organization. Clear? Right? So if நான் சொன்ன விஷயம் தான் வந்து பாத்தீங்க அப்படின்னா, you'll write in theory, right? You have to write MAR, how it is connected, MDR, how it is connected, what is PC, how ALU, what is the operation of multiplexer, what is the operation of general purpose register, right? And IR, PCR, special purpose registers, right? And you have to explain what is instruction decoder. All this you have to explain, correct? Right? And very importantly, right, you have to also explain, right now, we know that there are different generation of processor, right? In modern computers, like the processor speed are getting improved with every generations, correct? Right. So there are a lot of steps to improve, lot of techniques to improve the speed of the processor, right? And very importantly, right, how the speed of the processor can be improved, right, by performing parallel operation, right? By parallel operation, instead of doing one by one, we can do it by parallel operation, right? So there are a lot of techniques. The only important thing is mainly focus on parallel operation, right? There is two important concepts. One is pipelining concept. Pipelining concept. Another one is superscalars concept, right? Right. That is to improve the speed. There are different techniques exercised. What is meant by pipelining? Pipelining is nothing but, right, executing one instruction before the previous instruction is getting completed. Okay, that is known as pipelining. One by one, it will execute the instruction, but once the instruction starts the execution phase, right, it will go to the next instruction, right? It will not wait until that particular previous instruction is getting completed. Okay, that is known as pipelining. Parallelly, it performs the operation, right? And what is meant by superscalar operation? Superscalar operation is nothing but, so far what we have seen is in unit 2, processor will fetch instruction one by one and it will execute it, right? But superscalar is nothing but at the same time it will fetch a lot of instruction and execute it at the same time, right? That is called as superscalar operation, right? This is what you have to explain in single bus organization, okay? And if you take any particular any particular instruction, right? If you want to execute any particular instruction, you will have all these operations. That is, one is fetching the instruction from the memory, fetching the information from the fetching the data from the memory, right? And then you have to move the content, right, from IR, so from PC to IR, from one register to one register. You have to transfer the data. Then you have to do an ALU, that is arithmetic logical operation. And once the operation is completed, that result has to be stored in some register, right? So these operation has to be done in all the instructions, right? So it can be done once or more than once, right? You can see here, transfer a word data from one processor register to other register, perform arithmetic operation, store the result, right? Fetching the data from memory location, right? And store the data to the processor register, right? So these are the 4 steps which will be done one or more times for executing any particular instruction, correct? Right. So whatever information I have given so far, right, it can be explained in points, right, in theory. That is what we are seeing here. You can see you have ALU, temporary registers, and various digital circuits. The internal bus connects all those things, right? And very importantly, you can say as data path. What is data path? Is nothing but, right, the internal bus, and then registers, and then ALU, right? All these three can be commonly called as data path. Okay, and then I already explained what is the working of program counter, what is meant by MAR, right, and how it is connected, and what is MDR. I have said about 2 inputs and 2 outputs, right, and then you want to explain about the register, general purpose registers, why it is used, and I have said what is the use of Y, Z, and temp registers, right, and operation of multiplexer, correct, and then what about the ALU, how it is getting executed, and I said what is data path, correct, right. So hope you are clear with the concept. And unit 4 is very simple unit. You got to just draw the diagram and you got to explain. You got to understand the concept, how it works, so that you can very clearly explain it. Okay, so today what we have seen is we have seen single bus organization of the processor, right. Hope you understand the logic, right. Thank you, students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.